So this talk is a reverse proxy talk, and it will compare Varnish to Nginx. Now, each of these projects were built and developed in a specific country, hence a mixture of the flags. So, Varnish was developed in Norway. In the back, you see the Norwegian flag. And then Nginx was developed in Russia. I could have put up the Russian flag, but I decided to go with the Soviet flag anyway. So this won't be about politics or anything. This is just a comparison between two products built in different countries. So anyway, my name is Thijs. I imagine this is quite difficult to pronounce. Yeah, Thijs. Like, think of tasers, cops and security agents, Thijs people. Well, remember that and it'll be just fine. I'm a technical evangelist at a Belgium hosting company called Combel, and in my spare time, I run the Belgium, Netherlands, and Luxembourg user group for PHP. We have a conference. Who has heard of that? You've heard of us? Nice. Cool, thank you. If you want to follow me on Twitter, my full handle, or my full name is my handle. I'm semi-active on there. You can send me stuff. I will be glad to respond. Professionally, working at a hosting company, we're in the cloud, as you can see. Very clear. We do everything from your $99 per month up until your $99,000 per month. So we're just a mainstream hosting company, and we have some experience with the technologies I'm going to talk about. So it's basically what I learned over the years from both. But this presentation will basically be a feature-wise comparison, and I'll explain how Varnish does it, and I'll explain how Nginx does it. Now, before we continue with the actual presentation, I would really like you to give me feedback, honest feedback. So if you don't quite like it, you can say it, but please mention what I should improve, because I do a lot of presentations, and I would like to have either good ratings or good feedback so I can improve my talk. This is also important for conference organizers. If you give me a good rating, chances that I do this presentation again increase and increase. If I do a bad job, punish me for it, I will improve, and that will have an impact. So if you want to take a picture of the QR code, you can. There's also a direct link. So let's start. What's a reverse proxy? Who's heard about reverse proxies? Raise your hand, please. Okay, let's try the other way around. Who has never heard of reverse proxies? Okay, welcome. I hope you learned a lot of things. So a reverse proxy is basically a system you put in front of another system. That's a simple explanation. In our case, that will be not really a web server, but a server that speaks HTTP that you put in front of another server that speaks HTTP. So you have your typical web server, your Apache, Nginx, IIS, or what have you, and you put another machine in front of it, and the client communicates with the reverse proxy, and the reverse proxy communicates with the web server. Now, why should you do a thing like that? Why should you set such a system up? And I have various reasons. So, hide the origin server. That's a valid use case. That's not a use case I'm going to talk about, but it happens. You want to hide the actual server behind. You could do SSL termination. So not every system supports SSL, or you want to terminate SSL before you load balance. That's something you could do. And as mentioned, load balancing is something that reverse proxies do as well. You can do caching. That helps a lot. Who's been to the keynote this morning? He talked about caching, he talked about Varnish, he talked about Nginx as well, so I will cover this in great detail. And you can do compression as well, but what is my main interest right now is the caching part. We'll talk all about caching. There'll be a bit load balancing as well, just for being complete, but the main thing will be caching. And we do caching to protect our backend servers from being flooded, attacked, or stampeded. Because nowadays, it's not really the internet connections that are slow, because back in the day, there weren't reverse proxies, but regular proxies, and you put those in your own network to avoid your network connection being saturated. But nowadays, we have broadband, and it's the servers being attacked, so it's the next step. So we just place the proxy servers from the local end to the remote end to protect our backend from any evil there. And when I explain this to people who aren't that tech savvy, I always talk about the blockbuster movie, The Bodyguard. Who's seen that one? What was that, early 90s? Whitney Houston, Kevin Costner? Well, basically, Varnish or Nginx are Kevin, and our backend server, our Apache or our IIS, that's basically Whitney Houston. And the traffic, that's the stocky fan that comes to Whitney and asks for an autograph or a picture, and then Kevin steps up and says, no, face me first. And if the stocky fan asks a question that Kevin doesn't have the answer for, he talks to Whitney, asks the question, returns the response. So that's basically how it works. So if you're in doubt, think about the bodyguard. It's an important one. And because we're talking about reverse caching proxies for the web, we'll be talking about HTTP. And knowing the HTTP spec, or at least parts of it, will be essential. So who here, in his own opinion, thinks he masters HTTP pretty well? I see someone pointing at someone else. So I'm not the expert. I'll never claim that I'm an expert. But I have studied HTTP just quite a bit and enough to understand these things. But this is the main, like, if you have to take something home from this presentation, it's learn HTTP. It is essential to everyone who is involved with web-related technologies. And ironically, the things I hated most when I was a kid, so back in 1996, 1997, that's when most of us discovered the internet, right? 96, 97? Maybe in the States it was earlier when, so who was here on the internet early 90s, like really early 90s? Like I got internet as soon as I could, and it was like 96, 97. And I hated browser cache, because why would I want to have something cached? I wanted new results, and I knew if I refreshed or did some certain combos, I could actually see the real page, but I hated browser cache. Now I'm a tiny bit older, tiny bit wiser, and now I really appreciate the HTTP caching that is involved. And this is how it works. So cache control headers are a thing you could use. Like, everyone knows cache control headers, right? The nitty-gritty could be tricky sometimes, but basically, if you do cache control with a max age or a shared max age, you'll be just fine. A lot of people still use expires headers. I'm not really a big fan of that, but it works. But there's also a bunch of problems with that browser caching thing, because every browser has its own implementation. Okay, there's a standard you should follow, but there are deviations. You can also refresh your cache, so you could bypass it, force it. And there's a cache per browser. So although browser cache is good and it avoids requests coming into the backend server or even the reverse proxy, we'll mainly use those to feed data from the backend to the Varnish or Nginx. That's how we'll do it. But you cannot cache everything, right? There are some things that aren't cacheable by convention, and these are a couple. So usually we cache get or head requests, so post, put, delete. We usually don't cache those. Any idea why? There's this expensive word we use for that.
They're not idempotent.
Yes, idempotent. That's like the cool word everyone uses in the RESTful mindset. So if something changes, a post, a put, a delete, you can't really cache it, because you send a request to change things, and then what do you want to do? So only if there's a get or a head will cache. If there are cookies sent from the browser to the reverse proxy, or a set cookie sent from the backend to the Varnish or the Nginx, we won't cache either, because that implies a user-specific piece of data. So it's not something general you could cache. There are tricks, ways around it. I'll explain that later. But essentially, cookies aren't really cache-friendly. If an authorization header is being sent, this is not really something we can cache either, because that implies you're going to a protected zone where data is being presented solely for that user. So that's not something you could cache in general either. And if you do cache variations, who has heard of the vary header here? We'll talk about that for the people who haven't heard of it. The vary header is a header you could send, and it creates cache variations. So if you add a specific field or another header to the vary header, your browser or your reverse proxy will know it has to make a variation for each of those headers. So if you do a variation on everything, on an asterisk, you can't really cache anything, because everything has its own variation, so it serves no purpose. And finally, if the TTL, so the TTL is something you set via cache control, is 0 or less, we won't be caching either. So that being said, let's meet our gladiators. So at the left end, we have the Viking helmet that represents Varnish, Norway, so to speak, the Vikings. And on the right-hand side, we have the Soviet officer cap. He'll represent Nginx. Now, during this session, I will add these icons to the slide so you know what we're talking about, either Nginx or Varnish. I hope that makes things easier for you. So let's start with a basic intro of Varnish. Varnish was basically built by a guy called Poul Henning-Kamp. And the Varnish project was specifically built for a newspaper called Verdens Gang, a Norwegian newspaper. And Verdens Gang contracted a company called Linpro, Red Pill Linpro, to deal with it. They were looking for a way to make sure that the huge amounts of traffic they got from their Norwegian audience were dealt with accordingly. So Linpro hired Poul Henning Kamp to make it. Now, ironically, Poul Henning Kamp is not a Norwegian, he's a Dane, but the company who built it is Norwegian. So they started in 2005 with a bunch of ideas and trying to figure out what they wanted to do, and the first version was released in 2006. In 2008, we had version 2, and in 2011, we had version 3. I would very much advise you to use version 3. It's a real good one. I'll show you how to install it. Nowadays, the Varnish project has grown so big that it no longer fits within Red Pill Linpro, but there's a separate company being set up in that same group of companies called Varnish Software. They offer consultancy, etc., etc. Now, Varnish is only a reverse proxy. It doesn't do much else. Okay, it does a bit of load balancing, but you'll use it as a reverse proxy, not as anything else. So, Nginx. Nginx is a project developed by a Russian guy called Izor Susoev, or however you pronounce it. It was developed in 2002, first released in 2004, and we'll skip to the final bullet point first. It is not only a reverse proxy, it is also a web server. So that makes things interesting. And it was developed, the web server and reverse proxy thing, to deal with the CK10 problem from the get-go. So with the CK10 problem, we mean how could you handle 10,000 concurrent connections? That kind of problem. So Nginx was developed in a very asynchronous and event-driven way, not in the classic way that Apache works with the NPMs we know, like pre-fork or worker. It's entirely different. And they got 3 million funding from VC, so they now have the money to keep developing Nginx and make it better. And up to this date, it represents 12% and more of the internet. So 12% of all web servers are Nginx boxes these days. Okay, so we need to install those. So we need to make sure we have them up and running. And like, who here works with Linux servers on the usual basis? Okay, let's see another sort of show of hands. Who is more into the Ubuntu Debian camp? Any more of Fedora, CentOS, Red Hat people? Okay, I am more of a Debian, Ubuntu kind of guy, so I will show you how to do this via apt-get, but there are definitely RPM packages for this. So doing this is pretty simple, and if you go to the website of varnish-cache.org, there'll be install instructions for RPMs and Red Hat systems too. You can download the source and compile it from source if you want to. It's basically registering the channel, doing an update, and installing it, and you're done. These are the different channels either for Debian or for Ubuntu. You also see the key that you can use to authenticate. Same thing applies to Nginx. They have their own package server. I would advise you to use their packages instead of the default distribution ones. The default distribution ones are supposed to be more safe, but you miss a lot of features because they lag behind quite a bit. So I use the ones that Varnish and Nginx offer themselves because they contain the features we need. Once we've installed them, we need to configure it, right? So this is how you would configure a standard Varnish setup. So you go to etc default Varnish, and you configure the daemon options. And if you do a restart of the service, those options will be used. So you have the -a parameter that defines on which port and IP address it should listen. If you don't mention an IP address, as I did before the colon, all IP addresses will be assigned. And it makes sense to put port 80 there because we're doing HTTP, it's a standard port. And then the backend will be 8080 or another port you choose. You can also manage Varnish over telnet connection. You can see that with the -t parameter, -T. It's only available on localhost and on port 6082. To optimize the way we work with Varnish, we can define a certain rule set, and that is stored in etc varnish default.vcl using the -f parameter. And if we want to connect over that telnet connection, we need a secret key because otherwise everyone can log in and bring our Varnish down or retweak it. So there's a secret file. And in the end, you can choose what the storage mechanism is. So this was the configuration from a small virtual machine on my laptop, so I only assigned 256 megabytes of RAM. So that's the basic configuration. Once we dig into the VCL file that contains the rules, if you add that, just the backend connection to track back to the web server, you'll be just fine. And you can start caching straight ahead. Nginx is, as mentioned, a web server and a reverse proxy. So in that respect, you deal with the vhost style thing like you would define in Apache. So you add a vhost, you mention on what port it listens, to what vhost it listens. You can mention an error log, an access log, very specific and very also very trivial in terms of web server configuration. But then we come to the interesting part. There's a location block, and that's what Nginx uses a lot to do URL style rewriting, comparable to mod rewrite in Apache. They work with location blocks, so location / matches everything. So we match everything, we proxy pass it through on the local host on port 8080, same way we did in Varnish, and we define a proxy cache, which is called proxy cache in this case. Now, this term, proxy cache, is a given name. You could choose whatever you want. But, and on the next slide I'll show you, it refers to a certain space on the system. Now we can also define a cache key. So how would we identify a cache item? Well, we can do a shim, host, request URI. There's plenty of stuff to do. So in this example, we'd have separate caches for HTTPS traffic than for HTTP. If you want the same kind of cache, you just leave the shim bit out and it would be just fine. And finally, we define the TTL of the cache. So for all 200 and 302 requests, the cache lasts for an hour. So that's in the sites enabled. That's the way Debian and Ubuntu do it. It could be a bit different in Fedora or CentOS or Red Hat. You'll probably just use the conf file, the basic configuration file. And then, and that's where we get back to those proxy names, you have to define a path on disk where it should be stored. So I picked TMP and I gave it the name proxy cache. You could give it whatever name you want to. And we have 2 levels of caching. So that means it creates a hash directory, and within that directory, another hash directory, and within that directory, the cache file will be stored. Now the cache file could be 10 megabytes. If it's full, it will use the least recently used strategy and drop out the old stuff. And eventually, if it's inactive for 5 minutes, it'll get dropped. So these are parameters you can tune. There's way more parameters on the Nginx wiki, so wiki.nginx.org is pretty much the place to go to. If you go to modules and you go to proxy, you'll have all the details you need. And configuring our backend, well, this is how you would do it in Apache. Just change the listen port on 8080 and you're good to go. If you assign ports to your vhosts, you might want to change your vhost as well. So that being said, let's talk about PHP. We're all PHP people here, right? Now I want to see everyone's hands up. We're all PHP people? Yes. Except the sound engineer, he's not a PHP guy. So how would we serve PHP? What are the typical things we do? Before I spoil it and give you the slide, I want to check with you. So what's the basic setup you guys use for PHP? Do we use Apache? Who uses Apache? Anyone use anything else? Okay, Nginx FPM. Anyone use PHP on Windows? No one. I know some people who use PHP on Windows. It works, but that's all I have to say about that. So let's give you the explanation. Mod PHP is your typical way of installing PHP. If you do apt-get install Apache 2 and PHP, it will come in the mod PHP way. It has its upsides. It's simple. It's easy to configure. Performance-wise, it has some downsides. It could run out of memory quite easily. It could impact your CPU. You can split out those by using fast CGI and have separate PHP processes and separate Apache processes and tune the way Apache spawns these processes. And in the new way of doing, you could use PHP FPM. PHP FPM works best on Nginx, in my experience, but there are projects out there. If you use the old fast CGI module, you can connect Apache to FPM over a socket or over TCP/IP. Or with the improved version, you can use the module mod proxy FCGI, which is the officially supported version of Apache. So these are the ways we deal with things. But let me give you a nice little example how we could tackle that. Let's say we want to use FPM, but we still want caching, and we don't want to use Varnish. So this is an example. Okay, let us go through it. We set up default vhosts, which called nginx proxy.dev. So this is a configuration taken from my dev box. And we do a location tag, we match everything, and we make sure the index is index.php. So if we go to nginx proxy.dev, we'll fall back on the index.php. If a file would end with a PHP extension, we'll do some magic on it with the split path info, but we'll pass it along to the local host on port 9000. And that's the port where our FPM configuration resides. So FPM, for those who don't know, is actually PHP demonized. So the process management is dealt with by PHP itself. So you could connect via socket or via TCP/IP. So once you've got that set up, you can include some parameters, but the last three are very interesting because what you could do is cache that result. So instead of doing proxy cache, as you saw in the previous example, you do fast CGI cache. And you cache those results to a specific zone. In this case, we name it fast CGI-cache. And you saw in the previous example, you do proxy path, while you do fast CGI path, you define where you store it, levels of cache, the size of the files, just in a very similar way. And you define the validity, so I took an hour and I defined the key cache. So essentially, you have something that reverse proxies fast CGI requests. Because basically, if we run a PHP setup, the PHP files and everything behind it will be the slowest aspects. Because Nginx is pretty much tuned to deal with static data. So JS files, JPG, PNG files, those will go lightning fast and don't need to be proxied. Nginx can serve those in an event and asynchronous way. So don't worry about that. So this is a very easy way of caching your PHP. It's not the way, of course, but it's a viable way. And if you already work with Nginx and master Nginx pretty well, this could be your solution to the problem. Varnish doesn't yet support fast CGI backends, but they're working on it. So I hope for the next version we can do that as well. So we could connect PHP FPM to Varnish and not have anything else. Or we could even serve the static files from fast CGI via PHP and then just store them in cache. So there's plenty of ways of doing it. But once we've set it up, once we've configured it, there is some out-of-the-box behavior. There are some rules that need to be followed, very specific rules. These are the rules for Varnish. Varnish will not cache post, put, and delete, won't cache cookies coming in from the client, won't cache authentication headers, and if the backend sends a set cookie header, it won't cache it either. If the TTL is lower or equal to 0, won't cache it either. And if there's a vary header with an asterisk, so on all headers, it won't cache either. Now that's Varnish. Nginx has a bit of a different behavior, so it won't do post, delete, and put either. But if it sees a no cache, a no store, or a private header, it won't cache too. It will cache cookies. So cookies coming in from the browser, that it will cache. So there's a difference in behavior there. But set cookies coming from the backend, it won't cache either. If the TTL equals 0 is lower than 0, it won't cache. And if there's an XL expires header being sent, it won't cache either. So there's a difference there. But we should mention cookies because cookies tend to get quite confusing to a lot of people, including myself. So there's two ways of dealing with cookies. On the left-hand side, you have browser cookies. Those are cookies stored on your system in your browser, and those will be sent through every request. So every request that goes to that server, if it has a cookie for it, that cookie payload will be transferred over the wire. But you only have a cookie if there was once a set cookie. So if the set cookie is introduced, your system will accept that data, will store it. So I hope this is clear. I hope this makes sense. Yes? No? Makes sense? Okay, so I have two different kinds of cookies. One sent by the backend, one sent by the by the browser itself. Everything on the right here sent by the server implies changes to user-specific data. And to make sure that Nginx has the same behavior in terms of incoming cookies from the browser, you can use a trick like that. So you could set a sort of bypass flag, bypass variable in your vhost to 0. And if there is a cookie, so I like the way Nginx does this. It's like programming in a domain-specific language in your vhost file, just like Varnish does. So if there's an HTTP_cookie variable set, there is a cookie. So we set bypass to 1 and then do fast CGI cache bypass and fast CGI no cache. And you can do the same thing with the proxy thing, and it will just bypass the cache. So that will replicate the behavior that Varnish has for incoming cookies. Outgoing cookies, set cookies, that's pretty standard. So once we've set it up, we've configured it, we know what the default behavior is, we might get some traffic through it, and then you want to know how successful you are. So basically, you want to do some monitoring and logging. That's what you want to do. And there is a big difference in both systems. So Nginx works with access log and error log, just like Apache does. So it's basically a file that gets all the information. Varnish has more information. Varnish has more tools to do so. So there's Varnish stat, Varnish log, and Varnish top. Those are binaries that are installed upon installation. Let's talk about Varnish stat first. So this is what it looks like. This is, if you run Varnish stat, you'll get output like this. It's comparable to top on Linux, so it gives you some basic information. What you can retrieve from this is that the last 10 seconds, so all the way up on the left, the last 10 seconds, the hit rate was 84%. Over the last 100 seconds, the hit rate was 76%. And over the last 254 seconds, 254, it was 72% or 72.8, so almost 73%. So what you could retract from that information is that I've been running this script or this varnish stat command for the last 254 seconds, and the hit rate improved along that time. It improved from 72% to 84%. So that is a valid metric. That is something you could use in production to see. Now, this information does not come from files. It comes from RAM. So these are RAM logs. So that differs a bit. It's not that it's stored on disk and you retrieve it and you see what happens. No, this is real time. You have also other metrics, the number of client connections in absolute numbers or relatively speaking, the requests coming in, connections coming in, hits, misses. So this is a good dashboard you can use to see how your system is doing globally. But you also can dive in and see what exactly is passing. So we have the varnish log command, and when you execute that, you see all sorts of quirky output. So let's try figuring out what this is. So if you don't filter, because there are filter flags on the varnish log binary, so you can filter out specific requests or specific conditions and see what happens behind the scenes. So you see on the left there's a sort of sequential. This is sequential or number 11. And we open a session 2.12.12.12.1. That's the IP of my VM on port 80, which makes sense, right? You make an HTTP connection. I do a GET. So you see all the Rx request, Rx URL protocol and headers. That's my incoming request. So I connect to the basic page on that IP. I didn't configure a host name, so it's on the IP. I did it with my MacBook, and I think I did it via Firefox or so. I'm not exactly sure. And then you see my accept headers. And then a bit later, you see the VCL call piece. And it says, I received it, it is cacheable, and I will look it up in cache. Still with me on this one, yeah? You will look it up in cache. If you want to look something up in cache, you have to make a hash key. You have to find the key, the cache key. So it makes the key. And how does it make the key? It uses the slash. So the slash represents the URL and the host name, because you can have different host names or virtual hosts on the same system. And it retrieves it. It hashes it. But it missed. So you can see it lower. It missed. So if it misses, we have to fetch from the backend. So you can see all these keywords, and you can see exactly what happened. And we open connection number 13, and 13 connects to the default backend, and it opens it up. We retrieve the information, and all of a sudden, a bit lower before object protocol, we see hit for pass. And hit for pass means it retrieved the information, it stored it in cache, but it stored it in a blacklist cache. So it is not well cacheable. So something happened along the way that made sure that the response that was retrieved from our, in this case that was an Apache system, I guess, was not cacheable. And when we dig in a bit lower, all at the bottom you see no cache, no store, max age is 0, so that's probably the reason. So my backend system gave me a 0 time to live. So Varnish says, oh, 0 time to live, so we can't cache. So we put it in a blacklist. So that's basically how it works. And so on and so on. You see all the information that's being transmitted. So that's basically it. But you can filter in it as well. So if you have a very busy server and you open Varnish log, your screen will just go crazy. That won't really work. So what you could do is enter a -C flag, and the -C flag represents incoming client connections. So you only want to monitor what's coming in, not how Varnish connects to the backend. If you want to connect to the backend, specifically mention -B. The -M is a filter, so you want to filter out all requests that call a VCL hit. So that means all the hits. And you filter out via grep on Linux all the URLs. So what that gives you is this all the URLs that are hit from cache. Could make sense. You can also grep all the misses. So you could do that in this way as well. Filter on VCL call miss, get all the misses. You can use -A and -W to append stuff to a file. So if you want to use those log files, you want to store them on disk and use them later to warm up your cache, you can create some sort of scenario, let traffic through, save it in a log file, and use that log file to replay later. You can read that one as well to see what happened again, so you can replay all those logs and see what happened in the connection. And you can also filter on, let's say, headers, cookies. So what we do there is -I, lowercase, just includes all the tags you want to see. So we only want to see Rx headers, so those are HTTP headers coming in from the client. That's Rx. And we want to make sure that we only get the headers that include the keyword cookie. So I hope that makes sense. It's not an easy and very intuitive set of binaries to use, or binary to use, but it does the job. It basically does the job. You also have Varnish top, which is very similar to Varnish log, but instead of just doing it sequentially, it does it incrementally. So when I filtered on the user agent, this is what I got. So it got me all the different user agents. Could be useful in some way. Mostly you'll filter out the top misses, the top hits, and those sorts of things. These are, again, examples how to do it. It uses the very same syntax, but it uses a different binary. Instead of Varnish log, you'll use Varnish top. But I mentioned some keywords like miss, hit, fetch, hit for pass. Before we can understand that, we should have a look at the flow. And I hope this is readable, so I did a copy-paste of the exact flow published in the Varnish documentation. And it's kind of big, so boom, this is all we have. Let me go through it in a very quick way. Is this actually readable in the back? No? Okay. So let's try to do this in a very simple way. You receive the request. Let's try to point things out. You receive a request that is called VCL receive. If it is cacheable, it will get hashed. We'll look it up in the cache, and we will if it's there, we'll hit it. If it's not there, we'll miss, and continue. And otherwise, you have different mechanisms to do so. This is quite a pity that it's not readable, but it's a huge amount of information. Pasting it on these slides was very much a challenge. So let's just summarize what happened. So you receive a request. It will check if it's cacheable by default. So if it's a post, a put, if it contains a cookie, if it contains an authentication header, it will just pass it along to the backend. If not, it's cacheable by definition. So we look it up by making a hash. We look for the hash in memory. If it's there, we have a hit, we deliver it. If it's not there, we have a miss, we fetch it from the backend. If the backend result is cacheable, it will store it in cache and deliver it. If not, it will store it in a blacklist cache for a number of seconds, usually 120 seconds. And for those 120 seconds, all the next hits that come in will not get cached. That's the way it works. Now, every piece of that flow has a keyword. We have VCL receive, VCL fetch, VCL hash, VCL deliver. These aren't just clever names. These are subroutines we can hook into programmatically. And that's what I want you to remember from these slides. And these are the keywords you see. Receive, lookup, hash, hash miss, fetch, fetch, hit for pass. And we'll see that in a minute when we talk about VCL configurations. But before we do that, we need to show you how you can create your cache key. So this is how Varnish does it, and this is a small teaser. You see we have sub VCL hash, so that's actually hooking into the hashing logic. And this is how Varnish does it by default. We hash the data based on the URL, so rec means request, so it's a sort of object you can hook into, and we get the URL. So we hash that URL, and if a host is defined, we'll hash the host. If there's no host, and in my previous example there was no host, it was based on an IP, we will use that IP and hash it as well. So that's the basic thing. You can extend this all the way you want. You can add cookies, you can add specific headers, you can do all other conditions to influence the way it deals with cache objects. In Nginx, either if you use the fast CGI cache or the proxy cache, you'll just define a couple of keywords and it will use those. So in this case, we use the shim, either HTTP or HTTPS. We'll use the host name and the URI. But as mentioned before, you can hash cookies as well. Because that is a very typical use case. There are people that make websites that are used globally. So we have different regions or different languages. Let's use the language example. I'm a native Dutch speaker, so if I go to a website, I would prefer my website in Dutch. If it's not there, I'll go for English, and French would be my backup plan. So in a lot of cases, you have a global website, and they don't expose the language in the URL, or they don't use accept headers. So what they do is, you get a splash page first, you select your language, you click remember, and it stores a cookie in your system that has the language included. And upon all next requests, upon all next hits, it will know you are English speaking and you want English data. But you can't retrieve it from the URL. So if you want to cache those things, you might want to cache the cookie as well. Because towards the web server, your Varnish is a client. But towards the actual client, your Varnish or Nginx are just servers. So doing this is a trick you could use. So if you don't return anything at the end of your routine, it will fall back on the default behavior. and the default behavior was that. So that's one you should remember. If you don't return anything, this will be executed. So what we do is, before we hash the URL and before we hash the IP or the host name, we're going to look for a cookie called country. Let's say we want to have country-specific data. We hash that data, but not the entire cookie, because the cookie is just one string with semicolons as separators. So we just want to fetch out the country used in this case. So we have a function called reg_sub_all, which does sort of substring based on regular expression. So we look for the cookie, and we look for the cookie called country, and everything that is in those parentheses represents that country. And we replace everything else with, or we remove everything else and just keep, look, here, \1, we keep the language. So what this basically does is it stores the language or the country, it stores the URL, and it stores the host name. Because if you don't do that, and a French person goes to the website first, it's not in cache, it retrieves French data. An English person goes to the website, sees French data. So that's a way of doing it. It's not the best way. The best way would be use accept language or so and automatically retrieve the language settings of the browser. But if you can't do that, this would be a viable solution. You can do that in Nginx as well. So you just set the key and check if there's a cookie called country, use a sort of regular expression syntax as well, and add parameter 1 to your cache key. So that's the way you do it. But watch out for session start if you want to use PHP, or if you want to work based on PHP sessions. Every time you do a session start, it will do a no store, no cache, and a bunch of other things. Now Varnish could deal with that from a get perspective, but Nginx can't because there's no store nor cache. So that hit will miss. Want to remind you of that. So what we've done so far is install a caching system, either Varnish or Nginx. We tuned it, we set it up, we know the default behavior. There are some basic ways of monitoring, and we're in production. Now it's your job to choose an effective cache control time to live. So if you say it has to be cached for an hour, we'll take an hour. But all of a sudden, there's this breaking news coming in, or this really hot stuff that needs to be published on your website, and you can't wait another hour until it expires. So in this case, what you're going to do is you're going to purge the cache. That's what you're going to do. And there are various ways of doing it. Varnish has mechanisms for it. Nginx has mechanisms as well, rather limited ones, but they're still there. So this is how purging works in Varnish. And as you can see again, we're using the domain-specific language to define those rules. So sub-VCL receive indicates all the incoming requests. If the request equals a purge, so that's the keyword we're going to use. So if we retrieve a page via get, it will just retrieve it. If we do it via purge, Varnish will know that we're trying to empty that URL from the cache. If that is the case, look it up in the cache. If it missed, well, then it wasn't in cache, so there's no problem that you see in the bottom. But if it did hit, we're going to purge. And that's a very efficient way of doing things. You could do curl -X purge, call your web page, and it will be automatically deleted. So that's an easy way of doing things. And a lot of CMS systems use that way. I think WordPress does it that way. Drupal has a module that does it that way, but the main Drupal module that uses that is based on a telnet connection that does the purge. But if you want to do it over HTTP, this is the way you can implement this. But in Varnish 3, they introduced a new way of dealing with things called banning. We can still use the purge keyword if you want to. That's not the problem. You can name it whatever you want. You can even call it ABC123, as long as there's a convention between the backend system that does the purges and the Varnish or the Nginx. There is no problem. The banning syntax is a bit more flexible. Instead of just retrieving a URL and emptying it from or removing it from the cache, you can set up certain rules, certain specifications that the caching should respect. So in this case, we're going to match the host to the host, and we're going to match the URL to the URL. You can even match user agents if you want to. So the entire namespace, the entire requests object, or all objects you can match and put patterns on it. Because in the example below, we're not just removing one URL from the cache, we're removing a bunch of those because of the tilde sign right over here. So it matches everything. So if you have a website that starts with URL/XYZ, everything with XYZ and everything behind it, all URLs that match it will be removed. So if you want to do an efficient way of removing multiple URLs or multiple objects from the cache, this is a way of doing things. Now this mechanism will flag them as expired and upon the next hit, it will automatically retrieve the new data and replace it. If you want it to be gone immediately, you want to have to do smart bans. Now this is very complicated, but I'll try to explain in a simple way. It took me some time to understand it. So the banning syntax, the ban lurker thread, so there's a separate thread running in Varnish that looks for old data, and if it sees the old data, it will try to replace it with new data. But that mechanism doesn't have access to the request object, so it doesn't have access to the URL, and it doesn't have access to the host name, only to the cached object with the response headers. So if you want to make it aware of that, you're going to add some request headers to, or some response headers to it. So what you do is when you fetch it from the backend, you're going to add the X URL and the X host, because URL and host are usually part of the HTTP spec, but it's not stored in the object, so you add them. And you add the request URL and the host. But in the end, when you deliver it to the user, you want to remove those headers because they serve no purpose to the user. And then you match the X host to the actual request host, the X URL to the actual request URL. And when you do a ban in such a way, the lurker thread will see it, immediately remove it, immediately replace it with new content. So you don't have to wait up until the next hit. Your cache is fresh the moment you purge it. That being said, Nginx has similar ways. So Nginx stores everything on disk. You might think that is slow compared to Varnish that does everything in memory, but they have their stuff pretty much optimized. So what you could do is look in the place where you stored your cache. So that could be TMP cache or TMP. You define that in your fast CGI path or in your proxy path. You define where it is stored. And then you look for it. You do a grep based on the cache key. So in this case, it's shim host URL. Well, I'm filtering that one out. If you have a different key, your grep should look different. And once you've done that, you do an xargs and remove, and your cache is cleared. It's not that easy to work with, but there is an option for that. So a guy named Frickle, or who names himself Frickle, has created an Nginx module that does purging in a similar way. Now, that module is semi-stable, not 100% stable, and the documentation describes different things than what it does. And I noticed that the WordPress community created a plugin for that, so you could use Nginx as a reverse proxy in front of WordPress, and they use it in such a way, and that was the only way I got it working. So what you do is, instead of giving it a purge method, you just do a get, a regular get, but you add purge/URL, and then it'll get matched. That's the only way of doing things. And this is what a purge would look like. You go to your hostname, do /purge/your page, and it will be empty. So then again, you have to download that third-party module, and you'll have to install it. If you don't want that, you just have to grep to the file system and delete the files. Load balancing. We'll quickly talk about load balancing. Varnish has a thing called probes, where you could measure certain things. So what you do is you define a URL and a bunch of metrics like intervals, timeouts, thresholds, what you expect as a response code. And if it doesn't match that, it will flag that backend as unhealthy. So we define a backend here. You can define multiple ones. You could say, we connect in www.example.com. We pass it through to HTTP or a port you can choose and do health check on it. So this is a basic backend. But you can use directors, and that's another language structure, to aggregate all those backends into one backend that is exposed to Varnish. And based on the probes, it will make one or multiple ones healthy, and round robin through that, or use a different strategy, and all the ones that are unhealthy will not be used. So this is an example of a random one. So you define two backends, you add them to a director, give it a random keyword, and you can increase the weight by adding numbers to it, and then just set it here, set the request backend is localhost, and it will loop through it in a random way. This is active-active. If you want to do active-passive, you could create a director with a fallback one, and then the order matters. So in order it is defined, it will be used. So if backend 1 is down based on the probes, backend 2 will be used. You can also do IP hash. So you're going to make sure that if a client connects, it will remember its IP, and it will send it to the appropriate backend. Nginx does similar things. It does similar things, and it uses an upstream keyword for it, and it groups all the backends at once. You can do weights on it. You can use backends based on TCP/IP, backends based on Unix sockets. And then you do a location tag that catches everything, pass it along to the named backend, and it will just distribute it randomly. You can do fallback as well by mentioning the backup keyword next to one of those. It supports IP hash, in a very similar way, define your backends. You can define down if that one is down. You can interfere with that and use IP hash to indicate that we use the IP to determine to which backend it goes. That's basically it. Now, if you run all these things in production, sometimes you want to debug, and you're not going to use the log tools. You just want to see in Firebug or in your Chrome inspector view if it was a hit or a miss. And you can add custom markers to it. Like in Varnish, we do it in such a way in the delivering part, so that's the hook before you deliver the content to the browser. You can say if the object that's stored in cache has more than 0 hits, then we add a custom header called xcache that generates a hit. If it has 0 hits the object, well, then it's probably a miss, and you add that. And it's very easy. I use it in Firebug all the time for clients to see, was this page a hit or was it a miss? Nginx has a similar thing. You can add a header. You call it xcache or whatever you want. And there's a variable called upstream cache status. And it has a bit more information. It could be either miss, expired, updating, stale, or hit. So you have a bit of inside information on why it was a hit or a miss. So very interesting. Once we've done that, I want us to talk about the time to live. Time to live is usually defined by your cache control headers. That's the best way of doing things. You give the application control of the caching flow. And in Varnish, the order in which you use it is it uses the max age over as max age, so the shared max age over max age, which makes sense because that's what's defined in the spec. That's how Symfony works as well. Nginx prefers max age, so it's a bit difficult. So if you would switch up Varnish to Nginx, you might have different results because max age is a setting you will use to indicate the browser, the very specific browser, that it could cache it for, in this case, 10 seconds. And at the reverse proxy, if there is one, you could use it for 5 seconds. But Nginx ignores that. But if you don't have a good cache control discipline in your application, and you still want to have it in your application itself, or in your Varnish as well, you can override it. So what you could do is, at the moment you fetch the information from the backend, you could say, if the URL starts with blah or whatever, we're going to cache it for 10 seconds. So bresp represents the backend response. So we're going to force the TTL being sent there to 10 seconds. So Varnish will cache it for 10 seconds. If it is a different URL, we're just going to cache it for an hour. Nginx does it in a similar way by using location tags. So if the location is anything random, it will just use the proxy cache valid for an hour. If it starts with blah, we'll just cache it for 10 seconds. So again, very similar ways of doing things. Now, edge side includes seem to be the cool thing. Who uses edge side includes here? I don't use it myself, so it's a very cool thing. I want to play with it. It has so much benefits. David explained in his session as well that he uses it, but it's not that easy to use. Let's take our very standard layout. This is stupid PHP. That's a disclaimer I want to give you in advance. It's very stupid PHP just to prove my point. So your typical layout will have a header, a footer, a menu, and a main page. And yes, I am not a front-end person. I use tables to do this here. And I know. It's just, let's agree it's just to prove a point that you can do it. Eventually, we'll give the Twig templates or the templates to someone who's way better at this. But what you can do is include the header, include the footer, include the main menu, and include the main page. But what you want there is have separate time to lives. So the header will probably contain, after login, your name, hello, person, XYZ, so we don't want caching for that. The menu could be cached for 10 seconds in this example, whereas the footer will only be cached for 5 seconds, whereas the main page that contains all the cool information only gets cached for 2 seconds. So what we could do is define ESI tags. So who has never heard of ESI? That's an important one. Okay, ESI. Do you remember SSI from back in the day? Well, it's a very similar thing, but processed by the server. So what you're going to do is you're going to put a tag with a URL, and Varnish will just compose those. So it will look, okay, this is a separate URL, this is a separate one, this is another block, so it will basically represent the block structure of your website. And it will retrieve those and embed it into that page. So this means you can have separate time to lives without actually storing the entire page. You store fragments of pages, which gives you added flexibility. So what we do here is define an ESI tag. Now these ESI tags were invented by the Akamai company, the guys who do the CDN. So they wrote a spec on it, and Varnish implements a tiny piece of it. Not everything, just a tiny piece. So the source attribute is the main one you're going to use. And then Varnish will parse this and will give you nice output. And if the one expires, it will just retrieve that block and display it as an entire page. I've written a small view helper on this, but if you use Symfony, and a lot of you do, I hope, it's built in by default, and you can use it in your Twig templates. But I just wrote something stupid, again, to prove my point. You have an ESI function. If there's a surrogate capability header being sent by the system in front of it, so in that case, the Varnish or the engine, or mainly the Varnish, it knows that the system in front of it supports ESI. So if it contains ESI, in my surrogate capability header, I know I'm in front of a system that supports it. So in that case, I will send a surrogate control header back. So I'll send to Varnish, hey, you say you support ESI? Well, I support it as well, and I'm in control. So it will send the surrogate control header with the ESI tag in it. And it will just retrieve the page, send an ESI include. If we're not behind a surrogate capability header, so if it's not sent, we're not behind a reverse proxy that understands ESI, and we'll just include the file. So plain old stupid function, it will echo it, and if it knows it's behind Varnish, it will just give it to you in an ESI way. If not, it will just include it and embed it in that page and display it as a single page. Now again, Symfony includes this in a very intelligent way. If you work with Symfony, go that way. This is what the VCL could look like. You could have a surrogate capability header being sent, and the fetching part just checks for it and removes it and does ESI. Now, Nginx doesn't really do ESI. There is a module, I haven't played with it yet, and I know other people who are working on similar modules. So if you want ESI in a mature way, use Varnish. And if you want ESI for on your CDN, I think Akamai and other ones support it as well. So in that case, I would definitely go with Varnish. SSL is another tricky pun. Who uses SSL here or tries to cache SSL requests? Ooh, a decent number of people. Well, to start with, Varnish doesn't support it and doesn't want to support it. So Paul Henning-Kamp has these strong feelings and strong opinions about SSL. He likes SSL, but he doesn't think his system, Varnish, should deal with it. So if you want Varnish to deal with SSL, you're going to have to terminate it in advance. So either you're going to do it on a network level or in your load balancer, or ironically, you could put an Nginx in front of a Varnish. I've seen that being done. But Nginx does. Nginx does support. So this is a way you could do it. You could listen on, I think this is a typo, it's not port 43, it's 443. You put your certificate in it, you specify the host name, and then you could pass it along. That's a way of doing things. I've benchmarked all systems on a small VPS, so the numbers aren't specifically accurate, but SSL takes handshaking. So if you want to do that, it will create some extra load on your system. But then again, if you want SSL to be out there, you should just terminate it before your application and have your application entirely in HTTP. So that's being said, who won this battle? I can't really answer that question. Who thinks Varnish is the best tool to use? Ooh, only a couple. Who thinks Nginx is the best tool to use? Well, not that much either. Who thinks you should just use the right tool for the right job? So that's your answer right there. There is no real answer. Use the right tool for the job. And I think this is the end of the presentation. I thank you, and I would like to ask you to leave me feedback. Good feedback or criticism. Criticism is not bad, but tell me what I should improve, and I will definitely do that for you. Thank you very much. It was an honor to be here. I think it's time for lunch, right?